Hello, we're Group 3, and today we'll be presenting on the Arma study of Shiraz wine. More specifically, our selected paper goes through the characterization of the key aroma compounds in Shiraz wine by quantitation, aroma reconstitution, and omission studies. So firstly, I would like to quickly go over the contents of this presentation. The objectives of this research will be firstly explained, followed by different parts of the research. This includes the sample preparation, the analysis techniques used, how the aroma compounds were identified, how the aroma compounds were quantified, and to finish off this presentation, the aroma recombination and omission testing will be covered. We'll be having two results overview sections in order to summarize the key findings of this research. So why do we conduct this research? So firstly, there's very little information on aroma compounds of wine made from Shiraz grapes. And as of the publication date of this paper, no comprehensive characterization of Shiraz wine flavor has been conducted. So the objective of this paper, firstly, is to determine the aroma compounds in two ultra-premium Shiraz wine. The Shiraz wine used here in this research was a Barossa Valley 2006 wine and a Margaret River 2006 wine. Both are Australian wines. And the second objective was to conduct an aroma reconstitution of the Shiraz wine to see if a similar replicate can be made. And the last objective was to identify the key aroma compounds with a high impact to the aroma profile. This was done by assessing the AEDA values and their odor activity values.
So for the sample preparation, we use two methods for each wine. So the first sample prep is by the dynamic headspace. So first, you put the 10 millimeter of the sample into a vial and equilibrate with 30 degrees Celsius to separate out the gas into the headspace. And then you purge with the helium, which is an inert gas, to carry the volatiles into the column. And then next, TA trap is used to trap the volatiles. Dry purging process is used to remove any water from the trap by using a dry inert gas like nitrogen before the desorption at 280 degrees Celsius for 5 minutes to force the volatiles into the splitless injection port by the Gerso MPS2 multipurpose sampler. And the splitless injection is ideal for trace analysis of samples with very low analyte concentrations, such as by the dynamic headspace, to carry all the flow direct into the column. So for the next sample prep, is split into two steps. So first is the liquid extraction, which use the diethyl ether as solvent to separate out the nonpolar volatiles by the separatory funnel, as they're both nonpolar, and then wash with brine and anhydrous sodium sulfate to further purify and remove any remaining water. And then solvent-assisted flavor of evaporation is used, which is also called SAFE. Here by the diagram is numbered clearly. So the sample is prepared previously is put into the number one sample bottle here. And then the valve at number two is carefully operated, or it may be automatic to ensure that the valve is closed under the time limit to avoid any non-volatile escaping into the distillation bottle at the number three. And here warm water is used to increase the temperature, which causes the evaporation of the volatiles into the medium apparatus here. And the volatile compound are carried through into the recondensation flask at number four, or the collection bottle, and the non-volatiles are left behind in the inner walls of the glass in the middle section. The cold trap at number five is employed to prevent any contamination in the whole apparatus, and is filled with liquid nitrogen. Liquid nitrogen is also present at the around the collection bottle to convert the volatiles back into liquid state. And then the sample is thawed and can be used for further detection.
For the topic number 3, I will explain about the method of this article, the, the, the technique, how they analyze the compound in the wine Shiraz to result the data. So after the previous step of sample preparation through the dynamic headspace, liquid extraction and order, we will get the aroma sample. Then we're gonna use the technique called GCO. GCO, or the full name is gas chromatography or spectrometry. It is a technique used to analyze the volatile compound in the sample while simultaneously assessing their odor characteristic. The compound identified through GCO were then quantitated to determine the concentration in the wine, providing insight to the aroma profile of the Shiraz wine from the Barossa Valley and Margaret River region. GCO factometry help in understanding the sensory impact of the individual volatile compounds, contributing to the overall aroma of the wine and aiding in characteristic of the key aroma compound in Shiraz wine. So from the article, GCO was employed to identify the most significant volatile compound in Shiraz wine from the different regions such as like ethyl propanoate, dimethyl sulfide or DMS, and also oak revived compound in Barossa Valley wine, and also like some juicy compound like the 2 and 3 methyl butanoic acid, as well as rotandone in Margaret River wine. Since we talk about the gas chromatography technique, it is necessary to mention about the column that used to utilize to evaluate the headspace sample and liquid extract of the wine. In this experiment, there are two types of column that are selected. They are like DB wax and DB5MS wax. DB wax is a type of stationary phase commonly used in gas chromatography for separation and analyzing volatile compounds based on their interaction with the column materials. In the study, the DB wax column was employed along with the DB5MS column for evaluating other active region in the wines, with panelists assessing the aroma characteristic of the samples. The DB wax column is a polar stationary phase, while the DB5MS column is a nonpolar stationary phase used in gas chromatography. DB wax specifically designed for separating polar compound like alcohol, ester, and like the acid, making it suitable for analyzing complex mixture such as wine sample, where these compounds are abundant. In contrast, DB5MS is more suitable for separating nonpolar and moderately polar compound, offering a broader length and analyte that can be separated effectively based on their volatility and polarity. And the second technique is the GCMS. This might like look similar to the GCO, but use the mass spectrometer as the detector instead, as you can see. MS is very useful for the compound identification by analyzing the mass of compound as we get from the chromatogram and compare it with the reference mass spectrum, or also used to analyze the fragment pattern.
As mentioned in the earlier slides, GCMS or GC mass spectrometry is a powerful analytical technique in which is used in this study to identify and quantify the specific compounds in the two samples of Shiraz wine. Mass spectrometry basically works by measuring the mass to charge ratio, or MZ for short, of ions within the sample. And the specifics can be seen in the diagram provided to the right, where the sample must first be ionized, then accelerated, then deflected by a magnetic field into a detector, which then projects the deflection values into a mass spectrum. And by using a mass spectrometer on the given samples, we can potentially identify which like each and every compound by comparing the MZ values obtained against the MZ values of different reference compounds in a known database. And since many compounds can have the same MZ values, it is imperative to compare the mass spectrum to the referent compounds to further help identify the various aroma compounds, and in this case, in the sample of Shiraz wine. And another way in which we could also identify the compounds within our samples could be through linear retention indices, or LRI for short. And what LRI is a parameter which is used in GC to characterize and identify the compounds based on their retention times. And in this particular study, identification was performed by calculating the linear retention indices using an alkane C5 to 30 series and the obtained values from prior analysis. Then the values are then compared against LRI values from a database to fully confirm the identity of the compound. And in this case, the theoretical LRI value was calculated using the formula shown above. And for example, a value of 2062 would correspond to octanoic acid, and this could be seen by comparing the LRI value of 2062 to an LRI value within a known database, and in this case, in the table shown on the slide, and it corresponds to octanoic acid, which also has an LRI value of 2062.
Next will be a part in quantitation of aroma compounds. We'll be mostly focusing on table 4, which includes the concentration of the Barossa Valley Shiraz and the Margaret River Shiraz. On the first paper, we'll be discussing the volatile esters, acetates, acids, and alcohol. All the compounds of interest are highlighted in green in this page and this page. The method they used is stable isotope dilution assay to headspace solid phase microextraction to GCMS, and then here is the diagram. Next will be the monoterpenes. The monoterpenes in question are linalool and alpha terpinol, which in this case they used in the monoterpenes as internal standards in the wine to avoid the degradation in the GCMS during analysis. Next is the rotondone. The rotondone is determined with SIDA, which is again a stable isotope dilution assay and solid phase microextraction to gas chromatography to mass spectrometry. However, this one they used immersion SPME, which means they dipped the glass rod into the solution because the rotondone has relatively low volatility. Next is a beta damascenone. This method directly uses SIDA with the deuterated beta damascenone in alcohol, which in this case is ethanol, added to wine and then diluted, which will then be extracted with pentane and ethyl acetate, and the organic layer is then later put through the gas chromatography and then analyzed with mass spectrometry. Next is a volatile sulfur compounds. In this case, we have dimethyl sulfide, methanethiol, and hydrogen sulfide. In this case, we can easily use GC-SCD, which SCD is the sulfur chemiluminescence detector, which is a very selective detector for sulfur in gas chromatography. Lastly, we'll be discussing the volatile compounds. In many cases, these volatile compounds can be quantified with the other methods. However, this paper they referenced is using a stable isotope dilution assay. Next would be SPME, solid phase microextraction, and gas chromatography to mass spectrometry. Some things to include here are they initially used solid phase extraction coupled with solid phase microextraction since they had some issues with the extraction efficiency of the compounds.
So I would like to give a quick summary of the current results obtained in this research so far. So the acidity and concentration of the key aroma compounds were found, and in addition to this, the aroma extract dilution analysis or ADA values was also found for each compound. The AEDA value can give a rough indication of which compounds have a high impact to the overall aroma flavor. However, as we can see that many compounds have the same AEDA value. Thus, using the odor activity value will be more useful in this case. So the OAV was calculated by dividing the concentration by the odor threshold, and the high impact aroma compounds can be tentatively identified through this. We can see that the compounds with the highest OAV were similar in both the Barossa Valley and the Margaret River Shiraz wine. We can see that the highest OAV compound was ethyl octanoate with a value of 76 in the Barossa Valley and a value of 87.8 in the Margaret River Shiraz wine. So we can see that the order of compounds with the highest OAV is pretty similar in both Barossa Valley and Margaret River, being dominated by the esters and beta-demasquinone. Thus, we can imply to an extent that these esters and beta-demasquinone have a high impact towards the flavor profile of the Shiraz wine.
Next up, we will talk about the overview of the aroma reconstruction. The aroma compounds of the Shiraz wines from the Barossa Valley and Margaret River regions were characterized through GC olfactometry, followed by quantitation. Once the identity and concentration of the key aroma compounds were obtained, the two Shiraz wines were reconstituted by combining the 44 aroma compounds in a wine-like matrix. And if the reconstituted wine is considered similar to the real one, this will confirm our hypothesis that the compounds are indeed the key aroma compounds in the Shiraz wine. And just an addition, that while this table contains 46 compounds, only 44 of them were included in the process. Compounds occurring in concentrations far below their odor threshold were excluded from the blending in order to focus on the most impactful aroma contributors. The method of evaluating the wine samples was done through sensory descriptive analysis, where key attributes were evaluated by expert panelists through a blind testing session. The different attributes and their descriptions are listed here in this table. Overall, both reconstituted wines are considered in the good agreement with the real wine. This can be seen by comparing the red bar and green bar, which represents the real and reconstituted wine respectively. However, the reconstituted Barossa Valley wine was closer to the real one compared to the Margaret River, as seen by the larger difference in mean ratings in elements such as overall fruit and nail polish remover. The rest of the labels in these bar charts will be discussed later in the following slides, which will cover omission testing of both Shiraz wines.
And as for the omission test, it is used to test the impact and importance of the selected compounds on the aroma profile of the wines. In this case, the selected compounds are the compounds with difference in concentration between the two wines. And the test is conducted by excluding the selected components from the recombination of the wines. So the wine sample used in this test are the real wines, the full reconstituted wine, the wine without non-volatile compounds, the wine without the beta-damascenone, wine without dimethyl sulfide, the wine without fatty acids, the wine without linalool, the wine without oaky compounds, and like cis-oak-lactone, like vanillin and others compounds. And the last wine is the wine without ritandone. Um, and from this, we can also see the difference between the two wines and the impact on the impact of the difference in concentration of the compounds in each wines. So looking at the overall fruit attribute of both wines, The effect of omitting each components are very similar with some differences, such as omitting linalool cause the overall fruit in the Margaret River wine to have a marginal increase in intensity, and the overall um, and the omission of dimethyl sulfide and oaky compounds in the Barossa Valley wines have decreased intensity of the overall fruit attribute of the wine. And also the concentration of the difference in concentration of the components of the two wines have effect on the different aroma profile of both wines, such as in Margaret River, there are pepper and green aroma attribute in the wine, but in the Barossa Valley, there are dark fruit and cooked vegetable attributes, which are not present in the other wines. In the yeah, and so for the result overview of the omission test, so each components in the wines have different effect on the aroma profile of the wine, which is also depends on the concentration of those components. So for example, the non-volatile compounds, which are the blue bars, have similar effect on both wines. So when the non-volatile compounds are omitted, it reduces the intensity of oaky attribute, and it increased the intensity of chocolate attribute in both wine, which means that the non-volatile compounds enhance the oak attributes and mask the chocolate attribute of both wines. And next is omission of linalool, which is the orange bars. We can see it increased the overall fruit in intensity in Margaret River, but not in Barossa Valley. And also the omission of fatty acid, which is the purple bars, reduce the oak intensity in Margaret River, but increase intensity slightly in the Barossa Valley. And this is all for our presentation. Thank you for listening.